Today we're going to see how we work with the simple suspension system to generate the model either using block diagrams or using the bone graft modeling technique. Mhm. There we go. Okay, so let's just look at the situation here and do outline some steps to do this process. So why don't we just call it the steps? And then we're gonna say number one. Step number one. You need to recognize the elements you have. So we have, as we identified on the picture, we have a spring, which we call it C element. So that's one distinct element. We have the damper, which we could use with the letter R, or we have we could use D as well. And then of course we have the mass, which is our inertia element. So the first thing we go and do is identify the elements you have. Two, we need to make a free body diagram. Okay, after you make the free body diagram, you write the differential equations. Yeah, and then what we do is we need to shift this differential equations into graphical form. So you can say transform the differential equations into a picture. Okay, so transform the differential equation into a picture. Then you will say represent in the integrations on the input and output devices. Okay, so let's just do all those things. We haven't done those things yet, and we are going to, and we're going to have to do this. So I am going to say, okay, this is going to be my summation point, like there. And what are the different terms that we need to put? So we're going to say represent the integration input and output devices, and then run the simulation. Yeah, so this is what we're going to do. So the first thing we got to do is free body diagram we already have. Write the differential equations. We need to do that. Here, the way you do this free body diagram, let me see, let me just make some room in here. Okay, so write the differential equations. Mm, what's happening? Oops. Um, we have a little bit of a problem here. Yeah, there we go. Um, the thing is, we need to get out of this mode because um, we're in a mode that is outside of this. I want to, yeah. So let's write it. Okay, so we have the mass in here, and if you define this direction of motion as positive, um, positive for x and x dot, like this. And then what are the forces that the subject is to? Um, First of all, we'll have the weight that is acting here, which is mg. And then when this moves up, there's going to be a resistance the other way. So, in here we have this, in here is, if this moves up, the spring will try to pull it down. This would be the force acting down, and this would be the other one. This has the value spring 1 over. Hmm? Yeah, both are going down because what we're doing is we are we are moving this up a little bit, and when we move up, this pull down. So this is for the damper. So in here, the force of this is minus v times x dot, and this other one is k times x, and of course minus because it's negative. All right, so we have done the free body diagram. We wrote the differential equations. No, we haven't written the differential equations. And then we transform the differential equations into a picture and then represent the integration and run the simulation. So in here we have just done the representation of the equations, and in here you go and we say minus mg minus k times x and then minus the damper, which is minus b over x. And then this is equal to mass times the acceleration x. So now that we have the sum, we transform this into a Simulink block diagram where you have the summation of this. So we have in here, the first one is this minus mg, and that is a term here, positive term. And what am I saying? Positive negative term, because it's going down. So we still need to correct one sign here, which this is going to be a minus sign because it's going down. So if this is the case, so in here you're going to have minus bx dot this minus b times see following this is m double dot, and then this is going to be this is the minus mg. What I'm trying to say is that this step, step number 3 and 4, they are so interrelated because the summation of forces is what determines the acceleration. That's why Newton's law says that the summation of forces acting on the body is equal to the rate of change of momentum. So in here what happens is now that we have this, let me see if I put in blue. Okay, so we do the integration here. We do the integration There we go. So here we're gonna go like this, 1 over m. This will get us x double dot, and then you have moment. S dot, and in here you do 1 over, yeah, so this is 1 over s, and in here you have x dot, okay. So then we have to connect this one to this, and the other one we connected, and this is for k. So this is how we do the the block diagram method. I think there's a small mistake in here. Yeah. There is, what I was gonna say is that we need to erase it in here. One, no, it's already done. The last part of the connection is, it needs to be improved. This one. Yeah. So now we have completed this model, and now we can put the scope in here so we can see it. Yeah. So it's our task to translate this into Simulink. So I want to give you some tips on how to use Simulink for this purpose.
Where you find the spring?
Huh?
Where you find the spring constant?
I will give it to you.
But the spring being applied inside the diagram?
Yeah, it is.
Minus B.
See here? This is the spring constant. Right here. Yeah. So we have a, so at this point what we need is just the graph in here. So yeah, there we go. I think at this point we need to go to the Simulink. So in here we go here, and then we go to Simulink to, well, first of all, we have to go to MATLAB because Simulink is a MATLAB, yes, dependent. Yeah, there's this. MATLAB 2015 seems to take longer than 2013 to load, a lot longer. Mm. Mm. And we depend on it. We don't have a choice. I think it might turn out to be that when you're working on a PC with this setting, you may want to leave MATLAB on all the time, so you don't have to go through this reloading. And so it takes a long time. There we go. So we here we type Simulink, and then the computer will give us a Simulink display. Mm. Here we go. Still needs to work out a little more. Still waiting. I hope you guys are following me so that you can do your things as well. Mm. What I need is to get the prompt on the MATLAB, and I have to get the Simulink. There you go. Once you're here, you're gonna do the get the new file, and then we have it opens a window. And what you want to do is to this one will reduce this one. This one is important. Go to where it says commonly used blocks, and that should give you plenty of blocks to work with for what you need to accomplish. Huh? I'm sorry, what? Which one did I pick? This one that says commonly used blocks. So in here, what I would do is just bring in the ones that you're gonna need. Like, for example, you go up here, you're gonna need this guy. And you're gonna need this one. I think like 3 of these. We'll move them when we need it. We need 2 of these. We'll need scope to get the results. Where is my scope? Right here, right? And of course, we need the summation point. That is very important. In this particular case, we need to put the correct number of inputs and outputs. See how many we have? We have 1, 2, 3, and 4. So we have in here we have that this is a minus. And then we have the other two are also minuses. So here, and this, you put it like this. And then here you put the value of mass times acceleration, you know, the gravity. This is mg. Something is wrong. This is interesting. We need to put the value here, value of m. How come it doesn't specify constant value parameters if a constant value is a vector? I guess it wants to see a number. I always like to put m times g like this. Unless this version of MATLAB is not going to allow me to do that. No, it's nice. In fact, it isn't. Just put the value in there. All right, so in here you divide this by 1 over m. There is something wrong with the. I can't put the letter m. It's almost as if it is in a mode that wants a number.
But it's not the software because mine works. I use the M in it. So there's something.
Let me give a try, and maybe I'll save this and then I'll open it again. Save as. Desktop. And title save. So I'm going to click in here. And what happens is that if you close this and see, where is it? Yeah, right here. If you double click on this, it should come up. Yeah, see right there. So I have always been able to put variables. Anybody knows why? What is that? That how come mine doesn't? Yours probably wants. It's not gonna accept other than numbers, which is which is not 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 the case. See, I'm trying to put the letters. Yours work. Yeah, yeah, that's the way it's supposed to work. Mine will not accept the letters. See, if I put a number, then it does fine, which is not really not nice. If m is 1, this should be 1 over m should be 1 over 1. I don't understand why. See here. Hmm. Do you see what's happening also? Mine is behaving really strange because it's as if definitely there is something wrong with my MATLAB. Control I for inverse, and this should go over here. But do you see what's happening here? This is not very nice. It's as if it's repeating the elements. Definitely mine has some bug. I think I'm gonna save and then get out of MATLAB because it is not working well. You can always double click on this and MATLAB will come around. Will get restarted.
So what does the 1 over m block do?
Divides by 1 over m and leaves x double dot by itself, see? Right here. And then this integrates once, this integrates twice.
So you're getting rid of m.
Later on, I'm just gonna give the value of m later on.
Maybe you need to start doing a new program because that you might save something in that program. So
Also, you might be right.
you have to
You might be right that this file might be corrupted. We'll see. I think Mariana might be right because do you see what it's doing with this? Well, we'll give it a try. This should be over here. And this one, for it control I, should be over here. I wonder if it will accept now my, yeah, it does. This is supposed to work like this. See, this will accept the B, and the other one should accept K. There you go. All right. So this is the way the block diagram is built, and we can always do it a little nicer. Yeah. There you go. So what I need to do is I need to initialize here. Like say m is equal to 1.
You need to change it, the 10 because you left the.
No, I leave the 10 in there. This is okay. K is going to be like 30. And this K and then B, right, is like 2. And so now we can go over here and say, okay, run. And the computer will run. And this is, double click on the scope to see the line. And if I click over here, it shows that in fact it runs. See? That's how it works. So I would like to see that you try this for the mechanical system that we have for the standby. On Thursday we'll work on the electrical system. And we'll go over some of the slides in more detail. I don't want to make anybody.
Can you see your MATLAB there when you type in the MATLAB?
Huh?
I was wondering about, you guys when you type in the MATLAB precise
The numbers?
to be
Oh, she wants to see my MATLAB window.
Yeah.
Okay, yeah, sure. Sure. This is what I typed.